Okay, in this video I am discussing about Markovnikov's rule. Markovnikov's rule को the statement of Markovnikov's rule is when Hx where X can be chlorine, bromine or iodine is added to an unsymmetrical alkene. Unsymmetrical alkene means this is CH2 single bond CH2, both sides of this double bond are equal, so this is not an unsymmetrical alkene. If we consider propene, then both sides of this carbon-carbon double bonds are different. Here methyl group is attached, while in this side no methyl group is attached. Therefore, this is an unsymmetrical alkene. So Markovnikov's rule is applicable in this alkene, not in this alkene. And we can take another example. If we take this alkene, this is a symmetrical alkene, but when we attach a methyl group here, then this alkene is an unsymmetrical alkene. Therefore Markovnikov's rule is also applicable in this alkene also. Okay, now let us complete the statement of Markovnikov's rule. When Hx is added to an unsymmetrical alkene, the negative part means chlorine, bromine or iodine will be the negative part here. The negative part X goes to that carbon atom having less number of hydrogen atoms. So if we consider this alkene, then this carbon atom has only one hydrogen atom, while this carbon atom has two hydrogen atoms. Therefore less hydrogen is attached to this carbon atom. Therefore negative part Cl or Br or I will be attached to this carbon atom, while hydrogen will be attached to this carbon atom. So this is the example here. First example is when propene is treated with HCl, then Cl will add to this carbon atom having a single hydrogen atom, while hydrogen will be attached to this carbon atom. So we will get this as the measure product. In fact, Markovnikov's rule statement is about predicting the measure product of this reaction, while the minor product will be in which Cl will be attached to that carbon atom having less number of or more number of hydrogen atoms. Now second example is here. If we take this alkene as the example, then this carbon atom has 0 hydrogen atom, while this carbon atom has 1 hydrogen atom. So less number of hydrogen atom is present in this carbon atom. Therefore the negative part Br of HBr will be added to this carbon atom, and the hydrogen, which is the positive part, will be attached to this carbon atom which is having one hydrogen atom. Therefore this is the only major product. I am not writing the minor product here. Okay, let me write the minor product also. The minor product of this reaction will be this is 5-member ring, this is methyl, and bromine will be attached to this carbon atom. This will be the minor product. This is not major, this is minor. Okay, next example is if we consider this alkene and an unexpected product is the major product. Let us see, according to Markovnikov's rule, this carbon atom has one hydrogen atom, this carbon atom has two hydrogen atom. So Br, which is the negative part, must be added to this carbon atom for the major product, but this Br will be added to this carbon atom instead of this carbon atom due to some rearrangement taking place in the reaction mechanism. That will be discussed now shortly. Okay, now Br will be attached to this carbon atom, while this hydrogen will be shifted to this carbon atom, and hydrogen of HBr will be added to this carbon atom. So our product is, this is the Br, which is the negative part, will come to this carbon atom. So how this will be our measure product? That is discussed here. Okay, let us see the mechanism of Markovnikov's rule. Actually, Markovnikov's rule is an electrophilic addition reaction, which means the electrophile is added first and then a carbocation is formed. And it is very important to note that whenever a carbocation is formed as the intermediate, then rearrangement will take place to form a more stable carbocation. For example, let us begin the mechanism here to know the example. So this H plus from HBr, this H plus is from HBr, this H plus is added to this carbon atom, because of which this carbon atom, the secondary carbon atom, will carry a positive charge. Now this is the secondary carbocation, this is 2-degree carbocation. Now adjacent to this secondary carbocation there is a tertiary carbon atom. So hydrogen will, not methyl, hydrogen will shift, hydride shifting will take place. Now this hydrogen will go from this carbon atom to this carbon atom. This is the hydrogen, here comes this hydrogen, so we get a tertiary carbocation. And we know that in the stability order of carbocations, the tertiary carbocation is more stable than secondary, is more stable than primary. So this is a secondary carbocation which is less stable, and this is a tertiary carbocation which is more stable. So we get a more stable carbocation. From a less stable secondary carbocation to more stable tertiary carbocation, rearrangement takes place. Now a very important point here is, if methyl is here in this hydrogen's place, then methyl shifting will take place. Then also methyl shifting will take place. Very important to note. Okay, now this is a tertiary carbocation which is more stable. Br minus from this HBr, hydrogen goes and Br minus was left. So this Br minus ion will attack this carbocation to attach Br in this carbon atom. So from a more stable intermediate tertiary carbocation we get the major product, and the minor product will be that compound in which Br is attached to this carbon atom, that is not mentioned here. Let me write one more example here, one more example of rearrangement which shows the rearrangement of carbocation. Okay, let me write with the blue pen. This is the fourth example. Okay, fourth example, this is the fourth example. In this example, let me give this alkene, this is an alkene. Now when Hi is added to this carbon atom, hydrogen will be attached to this carbon atom first to form a secondary carbocation, but let me give the example of methyl shifting here. Suppose if one methyl group is attached to this carbon atom. Now let me write the mechanism here to have a more clarity. Now hydrogen is attached to this carbon atom, we have a secondary carbocation. Now this adjacent carbon atom is a quaternary carbon atom. This is a quaternary carbon atom. This is a quaternary carbon atom actually. So this methyl will be shifted from this carbon atom to this carbon atom. So methyl shifting will take place, CH3 shifting, CH3 shifting, methyl shifting will take place. Now methyl shifting will take place, so the rearranged intermediate in this case will be, this is hydrogen, I am not showing this hydrogen. Now this methyl group this methyl group is shifted from this carbon atom to this carbon atom, so this methyl group will be attached here, and we will have a tertiary carbocation here. So to this tertiary carbocation, the bromine ion, that is bromide ion, Br minus ion, will be attached to this carbon atom. So we will have the major product. This is our methyl group, this is our again methyl group. Okay, this will be our major product. Okay guys, thank you.